Welcome to aminacademy.com in electrical engineering regarding parallel plate capacitor. Let us do some solving problems. Look at this example. A parallel plate capacitor has square plates of side 5 cm and separated by a distance of 1 mm. Calculate the capacitance of this capacitor. Second one, if a 10 volt battery is connected to the capacitor, what is the charge stored in any one of the plates? Given epsilon 0 equal to 8.85 into 10 raised to minus 12 Newton meter square, Coulomb power minus 2. Here, the capacitance of a capacitor first. Capacitance equal epsilon 0 A over D, which is equal 8.85 into 10 raised to minus 12 Coulomb into 5 centimeter plate, that is 5 into 5, 25 into 10 power minus 4 meter square over the distance 1 mm distance, that is 10 power minus 3 meter. This calculation gives the value, therefore C equal to 21.2 into 10 power minus 13 farads, then which is equal 22.12 into 10 power minus 12, because one please go back, and this is farad converted to picofarad is 10 power minus 12 is picro, therefore you can say 22.12 picofarad. Then second part of the question is, if 10 volt battery is connected to the capacitor, what is the charge stored in the plates? Then second part, we know that Q charge equal to CV. Then C is 22.12 into 10 power minus 12 into 10 volt, which is equal 1.2 into 10 power minus 12, which is equal this much Coulomb, which is equal to 21.2 into 221.2 in micro Coulomb. That is this much charge. Micro means 10 power minus 2 minus 12. Question number, next question here. A parallel plate capacitor has a square plate 5 cm separated in we have done this one. Next question. A parallel plate capacitor filled with mica having that is capacitor mica, that is ER epsilon r equal to 5, relative permittivity. 5 is connected to a 10 volt battery. The area of the parallel plate is 6 meter square and separation distance is 6 mm. Find the capacitance and stored charge. Second one, after the capacitor is fully charged, the battery is disconnected and the dielectric is removed carefully. Calculate the new value of capacitance, stored energy and charge. Second part, after the removal of dielectric, since the battery is already disconnected, a total then total charge will not change, but the potential difference between the plates increases. As a result, the capacitance is decreased. First, we will calculate capacitance and stored energy. First, capacitance. Capacitance equal epsilon r, epsilon 0, A over D. Here, epsilon r relative is 5, relativity, and epsilon 0 is 8.85 into 10 power minus 12. Then parallel plate area is 6 meter square over distance between them is 6 mm. 6 mm, which is equal 6 into 10 power minus 3 meter. The calculation gives the value 44.25 into 10 power minus 9, because minus 12 and minus 3 go up as plus 3, so minus 9 farad. Here 10 power minus 9 is nano, therefore you can say is equal 44.25 nanofarad. The stored energy, we have to find stored energy. Stored energy, the formula equal to Q equal to CV. That is, C is 44.25 into 10 power minus 9 into voltage. 10 volt is supplied. Which gives 442.5 into 10 power minus 8. No, this is 10 power 9 only, because we are multiplying with 10 here. Which is equal 442.5 nanocoulomb, because 10 power minus 9 is nano. Then after the capacitor is fully charged, the battery is disconnected and the dielectric is removed carefully. Calculate the new value of capacitance, stored energy and charge. After the removal of the dielectric, since the battery is already disconnected, the total charge will not change, but the potential difference between the plate is increased. As a result, the capacitance is decreased. Here we will calculate that new capacitance will C over, that is C0 equals C over, because that dielectric is removed, therefore C0 equal C over epsilon 0, because there is air, that is 44.25 into 10 power minus 9 already calculated, and here that is removed, that capacitance dielectric is 5, ER is 5, so we divided that one, which gives, because it's dielectric is removed, therefore 8.85 into 10 power minus 9 farad and is equal 8.85 is in nanofarad. The stored energy remains same. The stored energy remain same. As 442.5 nanocoulomb. Hence, newly stored energy is Q0 equal stored energy remains same. That's Q squared over 2C0, which is equal Q squared epsilon R over 2C, which is equal epsilon R U. That is U0 is nu is epsilon R 0, which is equal pi ER is 5 into 2.21 already calculated microjoules. This is equal 11.05 microjoules. Therefore, increased energy is, it is delta U equal change in energy for 11.05 microjoule minus 2.21 microjoule. Before we calculated, then stored energy you have to find here. Already U equal half CV square, which is equal half into 44.25 into 10 power minus 9 into 10 square, because volt is 10 volt, so which is equal 2.21 microjoule. This microjoule is subtracted here, which gives 2.21 8.84 subtraction 8.84 microjoule. When the dielectric is removed, it experiences an inward pulling force due to the plates. The removal of dielectric, an external agency has to do work on the dielectric, which is stored as additional energy. This is source of the extra energy of 8.84 microjoule. We have done. Please subscribe our YouTube channel.